Imagine a world where the only thing pouring out of a truck's exhaust is clean, invisible water vapor. No soot, no smog, just pure air. Now picture fleets of ships, planes, and even factories powered by a technology so clean it could dismantle our addiction to fossil fuels. Why then, after decades of hype, haven't hydrogen fuel cells taken over? If humanity craves a green revolution, why do we see more Teslas on the road than hydrogen-powered vehicles? Could a Norwegian breakthrough finally tip the scales? The dream of hydrogen fuel cells has been alive for over half a century. They're the darlings of clean energy enthusiasts and scientists alike, touted for their ability to generate electricity by combining hydrogen and oxygen, while emitting nothing but water. The basic premise feels almost magical, a machine that runs on the universe's most abundant element, creating power with no pollution. So, where's the catch? Let's dive into the core of how this technology actually works. At the heart of every hydrogen fuel cell are two main pieces, the membrane and the catalyst. The membrane is the layer that separates incoming hydrogen and oxygen, steering the chemical reaction. The catalyst, usually platinum, sparkles with scientific promise. It starts and sustains the reaction, generating electricity. Plug in hydrogen gas on one side and oxygen on the other, and let the magic happen. Electrons are freed, current flows, and water is the only waste. On paper, this sounds like the end game for clean energy. But in real life, hydrogen fuel cells carry heavy baggage. For starters, platinum isn't cheap. It's rare, mostly mined outside Europe, and classified by the European Union as a critical raw material. Meanwhile, the membranes traditionally rely on fluorinated chemicals, or PFAS, substances increasingly linked to pollution and health concerns, earning the ominous nickname forever chemicals. The cost, environmental risk, and the need for rare resources have combined to ensure that hydrogen fuel cells remain, for now, a niche solution. Battery electric vehicles are surging ahead, driven by falling costs and immense government support. Each year, millions of new electric cars hit the road, while hydrogen remains mostly confined to a handful of demonstration buses, trucks, and research labs. But what if someone could change the math? What if hydrogen fuel cells could be made lighter, cleaner, and far cheaper, finally unlocking their full potential? Enter Norway's SINTEF Institute, a world-leading research powerhouse with a bold claim. They've just made a breakthrough that could transform the future of hydrogen power. In a study recently published in the Journal of the Electrochemical Society, SINTEF's team revealed a way to make the heart of the fuel cell, its membrane and catalyst, dramatically thinner and more efficient. They managed to slash platinum usage by an astonishing 62.5%. Imagine that, a fuel cell with less than half the precious metal, but all the power. As lead researcher Patrick Fortin put it, after a certain point, making the membrane thinner doesn't hurt performance. Most of the resistance isn't in the bulk, but at the surface. Their new membrane is only 10 micrometers thick, 10 times thinner than a sheet of printer paper. The result? Fuel cell performance is maintained, costs drop, and reliance on environmentally problematic PFAS is cut by a third. The implications are huge. If produced at scale, SINTEF estimates a 20% cost reduction, not to mention a smaller environmental footprint. Imagine hydrogen trucks, ships, or backup power stations that are as affordable as their battery or diesel rivals, but without the pollution. Could this be the moment hydrogen steps out of the lab and into the mainstream? But the Norwegian innovation is just one part of a global tidal wave of hydrogen activity. In the past year alone, the world has seen some stunning numbers. The Hydrogen Council's latest report highlights $320 billion in planned hydrogen investments. Bloomberg NEF predicts a 30% drop in electrolyzer costs by 2027. The Port of Rotterdam just committed over $1 billion to hydrogen infrastructure, aiming to become a key European hub for green energy. In the U.S., the Inflation Reduction Act is pumping billions of dollars into hydrogen startups, making America a global frontrunner. Electrolysis, the process of splitting water into hydrogen and oxygen using electricity, is getting cheaper and more efficient. According to ITM Power, mega projects producing 100 megawatts or more are now on the drawing board. Meanwhile, Nel ASA has secured a $25 million EU grant for a pioneering electrolyzer project in Norway. A quiet arms race is underway. Who can make hydrogen cheap and green, at scale? Despite all this momentum, the path ahead is anything but smooth. The single biggest challenge is cost. Producing pure green hydrogen is still expensive, especially compared to dirty alternatives. As Wood Mackenzie notes, Government incentives could reduce the cost of hydrogen by 40–50% by 2030, but without that support, the economics don't add up. And then there's the infrastructure puzzle. Unlike electricity, which flows wherever there's a wire, hydrogen requires a new web of pipelines, storage tanks, and refueling stations. A recent University of California, Davis study found that blending up to 20% hydrogen into existing gas pipelines is possible, but beyond that, leaks and materials stress become serious risks. Building out the rest of the infrastructure, a global hydrogen superhighway, will require trillions in investment and a level of international cooperation rarely seen outside of war or pandemics. McKinsey, in their June 2025 report, estimates that fuel cell trucks could reach cost parity with diesel by 2035, but only if production scales up, supply chains mature, and infrastructure arrives on time. A senior McKinsey analyst warned, hydrogen will play a key role in decarbonizing heavy transport and industry, but only if we solve the chicken and egg problem. No demand without infrastructure, and no infrastructure without demand. Let's not forget about competition. Battery electric vehicles are racing ahead. Their prices are falling, their range is extending, and governments are rolling out ever bigger incentives. For light vehicles and urban transport, the electric car is winning, hands down. Hydrogen's window of opportunity seems to be narrowing by the day. So, where does hydrogen have the edge? The answer, in the hardest to clean sectors. Heavy trucks pounding down the highway for thousands of kilometers, container ships crossing oceans, industries like steel and chemical manufacturing that guzzle energy in bulk. Here, batteries are often too heavy or slow to recharge, and hydrogen shines as a high-density, fast refueling alternative. But even in these sectors, the hurdles are steep. Hydrogen storage is tricky and costly. Compressed gas tanks are bulky and expensive, while liquid hydrogen is cryogenic and hazardous. Fuel cells must run reliably for tens of thousands of hours in tough conditions, and manufacturers are still racing to reach that holy grail of durability and affordability. At stake is more than just clean air. The energy transition has become a global economic arms race. Whoever wins the hydrogen race could capture trillions in new business, create millions of jobs, and reshape the world's energy geopolitics. It's not just about science, it's about power, money, and strategic dominance. So, is Norway's new fuel cell the silver bullet, or will the old challenges of cost, infrastructure, and competition push hydrogen back into the shadows? The experts are divided. Bloomberg NEF insists that government policy is the lever that can bridge the gap, driving investment and building the market. But even with political will, the technical and economic obstacles loom large. Meanwhile, some industry insiders argue that hydrogen will carve out specific niches, long-haul trucks, backup power, ships, becoming essential in places where batteries just can't compete. Others dream bigger, a future where hydrogen flows as freely as oil, powering entire economies. But will the world come together to make that future real? Or will hydrogen remain a niche player, useful but never dominant? As the world's biggest economies pour record investments into hydrogen, new breakthroughs like SINTEFs are rewriting the rulebook. Yet with so much at stake, one question lingers. Will policy, economics, and technology finally align to unlock hydrogen's promise? Or will another revolution slip through our fingers? In the second half, we'll dive deeper into global hydrogen investment strategies, the next wave of technical breakthroughs, and the battle to build a hydrogen infrastructure before the moment passes. Stay tuned. The next decade may decide whether hydrogen shapes the energy future or fades into a technological footnote. Let's fast forward. What could the world actually look like if these breakthroughs in hydrogen fuel cell technology truly take off? The landscape before us isn't just a single road, it's a network of diverging paths, some paved with gold and others littered with obstacles. Let's explore the possible futures, what's at stake, and what these choices could mean for you and the world around you. Picture this. It's the early 2030s. Thanks to innovations like SINTEFs, the cost of producing hydrogen fuel cells has dropped dramatically. New gigafactories for electrolyzers are springing up from Texas to Tianjin. Europe has just completed the construction of a vast, high-capacity hydrogen pipeline network, fueling not just heavy vehicles but steel mills, cargo ships, and even the grid itself. Bloomberg NEF foresees a 30% drop in the cost of electrolyzers by 2027, not a pipe dream, but a market expectation. The Hydrogen Council is tracking over $320 billion in planned investments. Imagine a world where green hydrogen drops below $2 per kilogram, outcompeting diesel, natural gas, and even some battery-powered systems in high-demand scenarios. In this future, trucks powered by hydrogen fuel cells start rolling off assembly lines in Germany, the US, and China, with costs finally on par with diesel by 2035, as McKinsey predicts. In ports like Rotterdam, massive hydrogen hubs send clean fuel to ships that once belched black smoke into the sky. Cities begin to phase out older, noisier backup generators in favor of whisper-quiet fuel cell stacks powering data centers, hospitals, and emergency services with water vapor as their only emission. But this is just one possible scenario, a best case powered by optimism, policy, and persistence. Turn the dial just a notch and a different path emerges. Imagine, instead, that hydrogen becomes a niche solution. Battery electric vehicles continue their relentless march, dominating passenger cars, light vans, even short-haul trucks. Hydrogen, limited by patchy infrastructure and slow policy, finds its stronghold in a few sectors: long-haul trucking across vast continents, ocean shipping, and factories requiring uninterrupted high-temperature heat. Here, fuel cells are vital, but the vision of hydrogen everywhere, at every pump, in every home, even in city buses, never really materializes. Another branch on this tree of futures, blue hydrogen. Here, innovation in carbon capture and storage allows companies to keep using natural gas to produce hydrogen, burying most, but not all, of the resulting emissions underground. This buys time for renewables and green hydrogen to catch up, but concerns linger. Methane leaks from gas fields, public skepticism of permanent carbon storage, criticism that this is just a new label for an old polluting habit. The most sobering risk? Momentum stalls, policy support fades, investment dries up. Technical challenges around fuel cell durability and hydrogen storage prove tougher than expected. Without steady hands at the tiller, in government, business, and advocacy, hydrogen remains promising, but out of reach. The world continues burning fossil fuels, and the window for meaningful decarbonization narrows sharply. So what's really driving which future we get? Here's what the experts, Bloomberg Neff, McKinsey, Wood Mackenzie, are clamoring for: government incentives, tax breaks, grants, and purchase mandates to drive costs down and scale up demand. In the U.S., the Inflation Reduction Act is already a game changer, making the U.S. one of the most attractive markets for hydrogen globally. Across the Atlantic, the European Union's Innovation Fund is pumping $120 million a year into research and pilots. Without policy pushing the pedal, most analysts agree, the hydrogen revolution simply won't happen fast enough. But there's another ingredient behind all this: international competition, even rivalry. While Europe and China are racing to build clean hydrogen supply chains, the U.S. is betting big, not just for climate reasons, but to secure energy independence and avoid future supply shocks. There's a global policy battle brewing over resource security, industrial jobs, even technology standards. Whether countries work together or go it alone could tip the balance between rapid progress and fragmented, inefficient rollouts. Now let's get practical. What does this mean for you, whether you're a business leader, a student, or just someone curious about the next era of clean energy? The implications are closer than you might think. If you're in logistics, manufacturing, or construction, the rise of cost-competitive hydrogen means new options for cleaner operations, and perhaps new rules from governments mandating low-carbon supply chains. Companies that start experimenting with hydrogen fleets now will be better poised as costs fall and policy incentives grow. Early movers could lock in long-term advantage, especially as clients and investors begin demanding concrete climate action, not just promises. If you're considering a career in energy, chemistry, or engineering, think about specializing in hydrogen systems, electrolyzer technology, or fuel cell maintenance. The skills gap is already real, and with over $320 billion in global investments projected, the coming years will see a surge in openings for people who understand both the science and the business of hydrogen. For policy watchers and activists, now's the time to push for smart, ambitious standards that reward clean hydrogen and penalize emissions. Transparent certification systems, making sure green hydrogen is truly clean, will be essential. International cooperation, not just competition, could help build global supply chains, lower costs, and avoid duplication. And yes, for everyday consumers, hydrogen could soon touch your life in subtle but meaningful ways. Maybe not in your family car, at least not soon, but powering the truck that delivers your groceries, the ship that brings your smartphone, the emergency generator that keeps your hospital running when the grid goes down. As infrastructure expands, some regions may even blend hydrogen into natural gas pipelines, as the University of California, Davis found, is technically feasible up to 20%. Cleaner air, quieter streets, and new economic opportunities could all flow from these invisible shifts. But let's not gloss over the critical lesson here. There is no magic bullet. Every green technology faces its own set of trade-offs. Batteries, wind power, solar, all have a footprint. Hydrogen fuel cells, even with less platinum and no PFAS, must still overcome tough hurdles. Making enough green hydrogen, storing and transporting it safely, building global infrastructure almost from scratch. What's different right now is the alignment of breakthroughs and billions. The innovation spark from labs like SINTEF's is meeting a storm of policy support and private investment. The next few years could determine whether hydrogen takes its place alongside batteries as a pillar of the clean energy economy, or whether it gets stranded again as a perpetual promise. So, is hydrogen's golden moment really here? The honest answer, it's closer than ever, but not yet inevitable. SINTEF's advances are a vital step, making fuel cells both cleaner and cheaper. The cost reductions and environmental gains are real, slashing platinum use by over 60%, cutting PFAS, even lowering overall membrane costs by 20%. Combined with policy momentum and colossal investment, the stage is set. But the final act depends on three things: relentless innovation, massive policy support, and public demand for real decarbonization. If any one of these falters, hydrogen risks slipping back into the margins. If they come together, the 2030s could see not just a hydrogen moment, but a hydrogen era. And here's the secret fact most people don't realize. The technology that could power tomorrow's trucks and tankers might also keep your neighborhood's lights on during the next blackout. In countless pilot projects across Asia, Europe, and the US, hydrogen fuel cells are quietly providing backup power for schools, hospitals, and even emergency shelters, delivering resilience as climate disasters become more common. A final thought for you: the future of hydrogen isn't just something happening in labs or boardrooms. It will shape jobs, investments, local air, and perhaps the fate of industries. Watch closely as governments roll out new incentives and as headlines announce each new fuel cell truck or hydrogen pipeline. The next decisions made by leaders, researchers, and citizens, including you, could tip the balance for decades to come. So, what do you think? Is hydrogen ready for its golden moment, or is it still chasing the spotlight? Drop your questions and thoughts in the comments below. We'd love to hear your perspective. If you want to keep up with the cutting edge of energy, subscribe and hit the bell, and check out our previous video on the surprising comeback of nuclear power. The